Hi everybody, this is the notes for section 1.8, the last section for chapter 1, dealing with some linear, all kinds of linear stuff. This one is absolute value equations and absolute value inequalities. Go ahead and take a minute, copy this stuff down, and we'll talk about it. Okay, I think everybody pretty much knows what absolute value does. Take the absolute value of a negative number, it gives you a positive number. This definition, it always caught me up a little bit, but if you read it very carefully, it makes sense. If x is less than 0, so it's negative, if you take the absolute value of a negative 5, it equals, what always caught me was this negative x here. The negative of that negative x value, there's your positive 5. It's just one of those things that it always threw me off, seeing an absolute value equal to a negative number. But the key thing was that you started with a negative x value. So the negative of a negative makes it positive. But that's the biggest thing. Just absolute values, make them positive. Make any value positive. Now, the key thing that we're going to be doing when you're solving these equations or inequalities is realizing you got two situations. All right, if we got the absolute value of x equals 5, there's two possibilities for x. X could be positive 5. X could be a negative 5. You plug in 5 for the absolute value, you get 5. You plug in negative 5 for the absolute value, you get positive 5. Two distinct possibilities of what's inside that absolute value. And that's the key way to think about these, is the inside stuff, the stuff inside of that absolute value. It could be positive or it could be negative, and you have to account for both cases. You can't just do one or the other. You got to do them both. So let's do some examples. All right, absolute value of 2x minus 1 equals to 3. Again, you have to do both cases. So the first case is always basically just get rid of the absolute value. It's the positive case. And you just solve for x like normal. Add the 1, divide by 2. There's one answer. Now, the other case is when the stuff that is inside the absolute value is negative. And that's how you set up that second case. At least that's the way I set it up. By doing it this way, everything, especially the inequalities, gets taken care of. So negative 2x plus 1 equals 3. Subtract 1, we get 2. X equals negative 1. Two answers. Absolute values are going to have two answers. And the reason for that, if we wanted to look at this graphically, we're just going to graph each side of the equal sign. Y equals 3 is a horizontal line. Okay, the absolute value of 2x minus 1. That graph is going to be, let's see, 2x minus 1, I believe, is going to look like this. I might be a little bit off, but it's close. 2x minus 1 looks something like this. And so the question is, when is the absolute value equal to, absolute value 2x minus 1 equal to 3, where these two graphs cross? Absolute value graphs are pretty much all, I should rephrase that. They're always going to be these V kind of shapes. And so when you got it equal to a number, this V is crossing that horizontal line at two different spots, at x equals 2 and x equals negative 1. Okay, so a little bit of a different problem, really just, again, in the setup. The algebra is pretty basic. So let's do the setup. You got the first case where all you're really doing is getting rid of the absolute value. It's the positive case. And then you would solve that for x. The second case is when the stuff inside of the absolute value is negative. Okay. And you just solve each one of those like normal. So let's just cruise through that. X equals 4 here, negative 2x minus 1. I'm going to add the 2x to this side, subtract 5. There's your two answers for this problem. All right, this bottom example, now we got this inequality. And this is where, if you look through the textbook at the explanations for these, they're telling you to do something different than what I'm telling you. And it's fine if you understand that way. It was one of those things for me that is always just, I got a little bit confused about what you're supposed to do. When are you supposed to change the inequality and change the number? I just never liked it. I don't like to have to memorize things and be worried about, am I changing it properly? Am I changing it at the right time? I didn't like that stuff. So by doing it the way I'm showing you with these absolute values, it takes care of all of that stuff. There's no confusion. It just becomes a normal solving process. So once again, with the inequality, pretend it's an equal sign. Positive of what's inside the absolute value. That's the first case. And the negative of what's inside. Everything about that inequality stays the same. You're just taking the two cases, positive and negative of what's inside the absolute value. And then from here, it's just normal solving process. Subtract 2, divide by 3. Here, you could divide both sides by negative first. It really doesn't matter. And so, I'll just go normal way. 3x, negative 3x minus 2 greater than 4. Going to add the 2, divide by a negative 3, so that changes the direction of the inequality, gives us this. Okay, there's our solution, and then to graph it, you just go to a number line. There's negative 2, 0, and 1. So we have x values greater than 2/3. Put an open circle there. We have x values greater than that. The other part of our answer is x values less than negative 2. Open circle there. And we're going that way. And there's our solution. All right. For this example, basically the same thing. I don't know why that check mark or the box is all highlighted. There we go. Basically the same idea. The solution looks a little bit different. So again, let's just fly through the algebra, then we'll talk about the difference in the solution there. Positive of what's inside the absolute value. Negative of what's inside the absolute value. Everything about the inequality stays the same when you set it up this way. So 5x greater than or equal to 6x, less than or equal to 6/5. Over here, negative 5x minus 2. Add 2, that gives us 10. Dividing by negative 5 changes the direction of the inequality. We get negative 2 here. Okay, so there's our solutions. We put this on a number line. There's negative 2. Here is our 6/5. We have greater than or equal to, so a closed circle. Change colors here. Closed circle at negative 2. We're going greater than that. At 6/5, we have a closed circle because of the or equal to, and we're going less than that. So our answer is really just this segment. On that last problem, we had the answers going from our two numbers and going towards the outside, to the left and the right. Here, we're going in the middle. So, it's a difference, but the setup is all the same. Okay. Go ahead and give this problem a try. It's one of the story problems. You'll have something similar to this in the homework. Try setting this thing up, and then we'll talk about it first thing in class on Tuesday. Have a good night.